The year is 1945. The war in Europe is ending, and American engineers move through devastated German cities. Amidst the cold and ruins, they notice something strange. Some homes are still warm, even with no power or fuel. In these rooms, a tiled structure, the Kachelofen, radiates gentle, lasting warmth. Unlike fireplaces back home, it keeps rooms warm with little fuel. The engineers expected advanced weapons, but found a marvel of survival technology. The Kachelofen was a hidden hero, a testament to simple, resilient design. Sometimes the best solutions have been there all along. What exactly was this Kachelofen? To Allied engineers it looked nothing like a stove, more like a massive tiled cabinet. Unlike cast-iron stoves, which cooled quickly, the Kachelofen offered slow, steady warmth. Its firebox was hidden, the heat radiating from its heavy brick and ceramic mass. No roaring fire, no clanking radiators, just silent, lasting warmth crafted by skilled hands. It was tradition refined over generations, a philosophy of building to last. The Kachelofen was folk technology at its finest, simple, robust, and perfectly suited to its purpose. In the world without electricity, it was a lifeline, a masterclass in efficiency and resilience. The Kachelofen's genius was in how it burned fuel. Instead of a slow, smouldering fire, it used a short, intense burn. Just one bundle of wood for the whole day. Air vents wide open, the fire roared to life, reaching extreme temperatures and burning almost everything, wood, gases, and all. The result? Almost no smoke, little waste, and a clean, efficient burn. The hot gases didn't go straight up the chimney. They wound through a maze inside the heater, transferring heat to the masonry. By the time the gases exited, they were cool. Most of the energy had been captured. This method was astonishingly efficient. Over 90% of the wood's energy was used. Compared to open fireplaces or even standard stoves, the Kachelofen was in a league of its own. In 1945, a family could heat their home for 24 hours with just scraps of wood. This wasn't just convenient, it was survival. The Kachelofen turned scarcity into comfort, using every bit of fuel to its fullest. In desperate times, that efficiency made all the difference. The Kachelofen worked because of thermal mass, the ability of stone and brick to absorb and slowly release heat. During the short hot burn, the heater charged up with energy, then radiated gentle warmth for up to 24 hours. The surface never got dangerously hot, making it a natural gathering place for families. Many homes had a built-in bench beside the heater, the warmest seat in the house. The Kachelofen became the heart of the home, providing steady comfort in a world of chaos. American engineers were used to fast, reactive heating systems, furnaces that blasted hot air on demand. The Kachelofen was different, slow to heat, but once charged, it offered stable, lasting warmth with almost no effort. It worked with the laws of physics, not against them. No moving parts, no complex controls, just mass and heat, perfectly balanced. The result was a home that stayed warm all day and night, no matter what was happening outside. In the coldest winters, This simple principle was a lifesaver. The catch-a-loafan showed that sometimes slow and steady really does win the race. The catch-a-loafan offers survival lessons for today's world. In an age of fragile energy grids, its ability to provide heat with minimal fuel and no electricity is invaluable. The key: use fuel efficiently. The short, hot burn extracts maximum energy from every scrap of wood. Modern rocket stoves and high-efficiency wood stoves use similar principles. Hot, clean burns for more heat and less smoke. Thermal mass is another lesson. Stone or tile floors, masonry walls and sunlit surfaces can store and release heat, making homes more efficient. The catch-a-loafan teaches us to value durability and simplicity. No moving parts, no electronics, just reliable, low-maintenance comfort. In a world of disposable appliances, this is a radical idea. The best survival technology is often the most robust and easiest to maintain. The catch-a-loafan proves that simple physics-based solutions can outlast and outperform the complex. The catch-a-loafan's strength was its simplicity. Built from brick, clay and stone, it had no pumps, fans or electronics to fail. When the power grid collapsed, modern heating systems died, but the catch-a-loafan kept working. Its operation relied on gravity and thermodynamics. Hot air rises, heat radiates. As long as there was something to burn, it provided warmth. Maintenance was minimal. Just remove a little ash and clean the flue every decade. Families could depend on it, freeing them to focus on survival. In contrast, modern furnaces are complex and fragile. One failed part, and you're left in the cold. The catch-a-loafan reminds us that true resilience comes from elegant, robust design. It was built for certainty, not just comfort. The catch-a-loafan's radiant heat was fundamentally different from modern convection systems. Forced air heating warms the air, which rises and escapes, inefficient in drafty, damaged buildings. Radiant heat travels in waves, warming objects and people directly, not just the air. Even in a cold, leaky room, you feel warm if you're near the heater. This made the catch-a-loafan ideal for survival in bombed-out cities. The warmth was gentle even, and deeply comforting. No hot or cold spots, no stuffy air. The engineers, used to the blast of a furnace, found this natural warmth luxurious. Radiant heat created a stable, human-centered environment. The catch-a-loafan delivered comfort in the harshest conditions with the simplest means. It was a powerful lesson in designing for real human needs. The story of the catch-a-loafan is more than a historical curiosity. It's a reminder that progress isn't always about complexity. Sometimes the best solutions are the ones we've left behind. The catch-a-loafan stands as a monument to clever design, durable materials, and a deep understanding of nature. It teaches self-reliance, warmth without dependence on fragile grids or distant suppliers. Its principles, efficient burning, thermal mass, radiant heat, are timeless. We can apply these lessons today, building homes that are more resilient and sustainable. The catch-a-loafan's message is clear: value resilience over convenience and simplicity over complexity. As we face new uncertainties, this forgotten technology offers practical wisdom for a safer future. The American engineers discovered more than a heater. They found a philosophy of living. Sometimes the answers we need are hidden in plain sight, waiting to be rediscovered.